Electrical safety. What is electricity? Electricity is a form of energy that is carried through wires. It is used to operate machines and lights, for example. There are two forms of electricity, static and current. Static electricity gathers in one place, while current electricity moves from one place to another. But how does electricity work? Electricity is the flow of electrons around a circuit. Electrons carry electrical energy from one place to another, creating current electricity or an electric current. For there to be an electric current, there must be a circuit, a closed path or loop around which an electric current flows. We must also take voltage and current into consideration when describing how electricity works. Voltage is a kind of electrical force that makes electricity move through a wire. Voltage is measured in volts. The larger the voltage, the more the current will tend to flow. Current is a steady flow of electrons and is measured in amperes, or amps. Together, voltage and current give you electrical power. The larger the voltage, the bigger the current, and the more electrical power you have. Power is a measurement of how much energy you are using each second. Power is often measured as a kilowatt hour. Let's discuss why electrical safety is important. Electrical incidents cause an average of 13 days away from work because of associated injuries and usually one fatality a day. So, always use caution when working near electricity. Workers are divided into two categories, qualified and unqualified, when working on or near energized equipment. Qualified workers have had training in avoiding the electrical hazards of working on or near exposed electrical parts. Unqualified workers have little or no training working on or near premises wiring for connections to supply electricity, installation of outside conductors, and optical fiber cables. Put simply, qualified workers can work with electricity, while unqualified workers cannot. Some hazards of electricity and electrical equipment include shock, electrical arcs and blasts, performing rescues, ground faults, extension cords, and broken or faulty equipment. There are many occupations that put workers at risk of electric shock. Some occupations include electricians, industrial machine operators, painters, riggers and roustabouts, stationary engineers, and welders. You can protect yourself from electricity by following specialized procedures in wet work areas, using lockout-tagout, conducting inspections, following assured grounding programs, using GFCIs, and guarding energized parts. Now, let's talk about wet work areas. If you touch a live wire or other electrical components while standing in even a small puddle of water, you will get shocked. Avoid working in wet conditions whenever possible and use approved electrical equipment for these conditions. Don't stand in wet areas when operating electrical equipment. Another way to protect yourself from electricity is by using proper lockout-tagout procedures. These procedures protect workers from the unexpected startup of electrical equipment and make sure equipment is de-energized before being repaired. Lockout-tagout procedures also protect you from electric shock. Visually inspect all electrical equipment before use. Equipment with frayed cords, missing ground prongs, and cracked tool casings should be removed from service. Assured grounding programs also serve as protection. They include a written program, daily visual inspections, and a method to detect the faulty grounding wire in an extension cord or hand tool. Grounding gives a stray current somewhere to go and keeps workers from becoming part of the circuit. but what must be grounded? All circuits, extension cords, and non-current carrying metal parts must be grounded. Also, portable and semi-portable tools and equipment must be grounded unless they are double insulated. Ground fault circuit interrupters, or GFCIs, are used in wet locations, construction sites, and other high-risk areas. They interrupt the flow of electricity within as little as 1/40th of a second to prevent electrocution. GFCIs compare the amount of current going into electric equipment with the amount of current returning from it along the circuit conductors. If the difference exceeds 5 milliamps, the device automatically shuts off the electric power. Guarding, another form of protection, involves locating or enclosing electric equipment to make sure workers do not accidentally come into contact with its live parts. This requires equipment with exposed parts operating at 50 volts or more to be placed where it is accessible only to authorized workers qualified to work with it. Electrical hand tools should be double insulated. These tools are encased in plastic, which will prevent a worker from being electrocuted if the tool short circuits. Electrical hand tools are identified with a square within a square logo or the words "double insulated" on the label. There are many types of PPE specifically designed and approved for electrical work. Some examples of this equipment includes rubber insulating gloves, matting, blankets, covers, line hoses, sleeves, Type E hard hats, and flame retardant clothing. You should follow rescue procedures if an incident involving electrical equipment occurs. If your coworker sustains an electrical injury, de-energize the circuit before getting help. Do not try to pull someone off an electrical circuit. Stay safe.